So looking at section 7.2, and we're looking to try and use these angle addition formulae that we've got. Now if we just flick forward straight away as far as the exercise, look at the numbers that are involved in the exercise. So there's 15, 75, 120 and 45, 165, and perhaps these numbers don't sort of ring a bell or say anything particular to you straight away. But let me just remind you of this. If I ask you to find sine or cos or tan of particular numbers, the numbers that we know the exact values for are 30, 60, 45, and then multiples of 90, okay? So if I ask for sine, cos or tan of any of those angles, you can find them exactly. So if we now go back to the numbers in the exercise, and we keep these numbers in mind, well, cos of 15, well, 15 is the difference between 30 and 45. 75 is a, is a 45 plus a 30. 120 is 90 plus a 30. 45 degrees we know. So all of these numbers are sort of combinations of these numbers here, okay? So once you realise that, what they're asking us to do here is to deal with, well, cos of 15, let's take that as an example. That's the cos of 45 minus 30 degrees, which is cos, sine, it's cos, so when there's a minus sign here, there's a plus sign here. 45, 30, 45, 30, and that number, and that number, oh, excuse me, there we go. So cos is cos, sine, 45, 30, 45, 30 with a plus sign in the middle. All four of these numbers are things that we can calculate, okay? Or we're not calculating, in fact, things that we know exactly. So once we've got that, we can plug them in and we can find exact values. And that really is the kind of thing they're asking us to do in exercise 7b, okay? So they've given us an example 5, exactly like that, sine 15. Now, if you were just met with sine 15 and you hadn't thought of this before, you wouldn't think, oh, well, 15, the important thing about 15 is it's 45 minus 30. You know, it's also, I don't know, it's also 25 minus 10, but that's not going to help us. The reason they picked the 45 and the 30 is because they're part of our special list of angles that we can find exact values of sine, cos and tan for. Now, obviously that is going to be true as well for radians. So if you look at this kind of example here, there are certain radians that we know, and those radians just correspond to these angles in degrees. So it's pi by 6, pi by 3, pi by 4, pi by 2, and then multiples of pi by 2, okay? So multiples of 90 degrees. Now, the other thing that these these angle addition formulae will let us do is have another method for solving this kind of question. So given that sine A equals this and cos B equals this, find the value of these things. So we've seen questions like this before where they give us an exact value of sine or an exact value of cos, and they ask us to find, well, a typical question would be sine A equals minus 3/5, find cos A, find tan A, okay? Now in this case, they can ask us to do these things. Well, how do we do this? Cos A minus B, we can write out using the formula. So I can find the exact value of cos A minus B as long as I know cos A and cos B and sine A and sine of B. Well, I know sine A and I know cos B, so I need to find sine of B and I need to find cos of A. Well, if you know this information, we have a technique from earlier in the book for finding sine of B, for finding cos of A. And if you know this information, we have a technique from earlier in the book for finding sine of B. Now, I'm not going to run through that now because we've seen that, you know, I've done other videos on it. If you flick back to the, in the playlists, to the AS trigonometric chapter, and I think I even ran through a method in chapter 6 for a similar kind of question. So this is just another one of those examples. We've seen loads of these so far through the books of taking things that we know and combining them in new ways to solve new kinds of questions with the new information that we've got. But really the techniques there are things that we already know. So that takes us up to the end of section 7.2.